Hello everyone, my name is Roy Jafari, and in this video I'm going to talk about dimension reduction for classification algorithms. If you haven't watched my previous video on classification algorithm, before continuing to watch this video, go back to that video and watch it. In this specific video, although I will shortly discuss classification algorithms and what they are, but the majority of the time that we will spend together during this video is going to be spent on dimension reduction for classification algorithms. It's very similar to the other video that I recently created about dimension reduction for bit prediction. The concepts are very similar, but the tools that we use are different. So in this video, we're going to cover those two. For a small recap, let's talk about what classification algorithms are first, and then we'll get to the code. So classification algorithms are basically a methodology or algorithmic way of going through to data to create or find a connection between independent attributes of a data set and the dependent attributes of a data set. The dependent attribute of a data set could be anything that we are interested in. In this specific example, we are going to be talking about churn prediction. So we want to be able to see if there are relationships among the populations of customers that will lead to them to churn. By churning a customer, I mean the customer will stop using our services and use services from our competition. So it is in our best interest to sort of detect who is likely to churn, and if they are valuable customers, we want to do things to hopefully keep them with our business. So let's look at our code next and see how we can go about it. Alright, so here it is, our Jupyter notebook file that I have all the codes here. We are going to be using a dataset, churn dataset. You can download this churn dataset from my own Kaggle profile that I have shared this dataset there. So we first import the module that we're going to be using here, and then we read the data, customer churn.csv. We can see in this data we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 independent attributes that we want to see if using them we can find a relationship between these independent attributes to the dependent attributes, that is churn, among the population of this data set. Let me go back to my PowerPoint slide in a minute and sort of show you what I mean by this connection. So here is, a classification. It's a display of classification algorithms in general. But for this specific case that we have just loaded the data on Jupyter Notebook, this is what we are trying to do. We are trying to find an algorithm that can find a relationship between these attributes, these independent attributes, and the dependent. And by being able to find that connection, we will be able to use this trained algorithm to help us about figuring out about the future customers' likelihood of churning. So let's get back to code. All right, now that we know our data set and we do know what task we are trying to do, let's just go ahead and do this with a decision tree specific for a classification. So, I'm specifying my X train, which is the independent attributes, and all of the data except the churn, so all of these except churn, and then a Y train, which is a dependent attribute, as the attribute churn. And then I'm using decision tree classifier from the scale-learn.tree module. And then I use plot decision tree from py.plots module. So once I run this algorithm, once I run this code, it will give me a decision tree that has used this data set to see if there are meaningful patterns in the data that helps us find relationships that will lead to distinction between churn and non-churn. So here, for example, we can see a very important attribute that can help us in that distinction is the presence of complaints. So now that we were able to do this, we can sort of now this new customer, so you can see we had like 3,149 customers here. We can have another customer and sort of use this decision tree to see what will happen to this customer as far as them churning or not. So you can basically use the tree that you trained. See, when you say fit, you're training this tree based on this data, and use the function predict to see what's going to happen to the new customer. So once I run this, now it's telling me it's going to be 0, which is this customer is not going to churn. Let's take a minute and sort of go through this tree our own, instead of asking the code to do this for us. So the first thing we need to check is what is the status of complaint. So the complaint is 0. Complaint is 0. It's smaller than 0.5, so it's true. Therefore, we come from that node to this node, and then we check the status. Status is 1. Status is 1. It's smaller than 1.5 is true, so we come to subscription lengths. Subscription length is 31. Subscription length is not smaller than 10.5, therefore it is false, so we come to this node, and then we check customer value is 712. 712 is not smaller than 434, so we come to this node, which is 0. So we figure out that, based on this tree, this new customer, based on their customer value, subscription length, and status and complaints, it's not going to churn. And basically that's what this code has done as well. So we came to the same conclusion. So this was a very short summary of what classification algorithms do for us. But the point of this video is for us to go about dimension reduction. Dimension reduction is the fact that we are saying there might be a smaller set of these independent attributes that can be more successful in predicting or classifying churn. So we sort of want to find that smaller set of independent attributes if they exist. So there are a couple of methods, and these methods, for specific cases might be even better. So it's not like all of these methods are good or bad. One of them is the best. Based on different cases, different situations, you might be using, either of these methods, basically. So the first one is a statistical method. With a statistical method, we are going to use a statistical, algorithm or model to sort of see if there is a meaningful relationship between each of the independent attributes and the dependent attribute. So since this is a classification algorithm and it's a binary classification algorithm, we can use the logistic regression model. So it's very similar to linear regression model as far as us typing the code, but here we have to use the logistic model. And once we run this, the algorithm will tell us that some of these attributes are not significant. The relationship between them and the churn is not significant. So we can see here, if I'm strictly statistical, I can say that, for example, second of use and churn, there is not enough evidence. When I look at the p-value, there is not enough evidence to reject a null hypothesis that there is no relationship between second of use and churn. So I cannot reject that there is no relationship between, I cannot reject this hypothesis for second of use, for distinct call numbers, for age group, and for age. For the rest of them, at the significance level of 0.05, I can reject that null hypothesis, and that means these attributes can be meaningful in prediction of churn. So, when I am doing this, sort of figuring out which ones are actually useful, these attributes are significant in prediction of classification of churn. All I'm doing is I'm checking the p-value if the p-value is greater than or smaller than 0.05. 0.05 is the significance level that everyone uses. So, you can use sort of like stricter significance level, which is smaller than 0.5, 0.05, or somewhat looser significance level, which is greater than 0.05. What we are deducting here is that call failure, complaints, subscription length, charge amount, frequency of use, frequency of SMS or text messages, tariff plan, status, and customer value, all of them show significance in the prediction of churn. And if we go back to the decision tree, we can actually see these are, for the most part, the attributes that the decision tree algorithm chose to use. Take a look at the second method, which is the correlation analysis. In this method, basically we run a correlation analysis among all of our independent attributes. In this method, what we are not concerned with is how each attribute is capable of predicting churn. What we are concerned with is how much collinearity or correlation exists among the independent attributes. This could be a case of data redundancy, and we want to see if there are cases of data redundancy, and if there are, we want to get rid of them. So we do the correlation by the function pandas function.core, and these are all of our correlations. Let's make it a little bit easier and just use the rule of thumb, which is the correlation, the absolute value of correlation. If it's greater than 0.7, it means that we have red flags as far as data redundancy. So let's do that using a Boolean mask. We can see there are some cases here. For example, we have frequency of use and frequency of 6 seconds of use are highly correlated, which makes sense. If we look at the data. And then we see that frequency of SMS and customer value are also highly correlated. And this also makes sense for this data set because, in the time that this data set was collected, the most revenue of these telecommunication companies, this specific telecommunication company, were coming from the customers who were using text messages. So this makes sense for this data set. Then we also have distinct call numbers and frequency of use also are highly correlated. And I think we talk also age and age group, which makes sense. Age and age group should be correlated. So based on this observation and the previous observation, so we should put all these sort of findings together and then choose between these sets. We have to either use second of use or frequency of use because they're highly correlated. But both of them showed to be possibly useful in classification of churn. Again, between distinct call numbers or frequency of use, between frequency of SMS and customer value, and between age or age group. Actually, we don't want either of these age and age group because based on our previous method, we saw none of them have values in predicting or in classifying churn or not. So we go to our third method. The third method is decision tree. Decision tree is a classification algorithm. You could use it as a classification algorithm, but sometimes some people just use it as a dimension reduction algorithm. So basically, it's very simple. You run a classification algorithm, you run a decision tree on your data, and basically look at the highest branches in your tree. And those highest branches, most of the time, are the ones that were the most valuable to the tree for sort of like segregating between your data. When we will talk about this decision tree in one of the futures video. When we talk about that, you will understand the mechanism of decision tree and how this is done, and how decision tree sort of like uses some metrics to find the most valuable attributes in as far as sort of like segregating between the data between chain and non-chain. Basically, I mean, we've already used the method 3, which is the decision tree. The last method is random forest. Random forest method is basically the same as random forest for prediction, the dimension reduction. Here we basically run 1,000 different estimators, or here decision trees, and see among all of these different randomized run or experiments, which of those attributes tend to come up or tend to be more important more often. So once you run this, it basically gives you a bar chart and a list of attributes among the independent attributes. Actually, it gives you a list of all of them that sort of like going to be in a sorted list, that the ones that are on top are the one that appear in the important attributes in sort of like segregation between chain and non-chain more often. So by looking at this sort of like list, and also the bar chart, and also it also includes the standard deviation in the bar chart, you can see that complaint, second of use, status, subscription length, frequency of use, and customer value were the most important attributes in the prediction. And also see age group, age, charge amount, the ones that sort of like were not important in the first method also are not important here. By looking at these different output or these different reports, you have much more knowledge about which attributes are meaningful or useful for the classification of